for product. Okay, and then the second one is the dual type. We have 3 types of dual type here. Okay, one is like this. Okay, A dot S plus S, meaning have one vacant. Okay, so if one vacant, we have to write like this, and then this is B attached to the side, and the A transfer to B here, so this one become vacant. So A dot S plus S to B dot S plus S. So this become like this. Can you see? Become like this, KS C A dot S CV, because vacant, site. And then CB dot S same S is CV, become like this. So the second dual type is like this. Both A and B attached to the each side. Okay. So the reaction become like this. And then the product also C and D. So we have all of occupied site. Okay, A and B for the reactant, and then C and D for the product. So from this we can write like this. Okay, and then this is different type of site. Okay, you can see the shape is different. So we can write like this. The A, we can write like this, A dot S. This one we write S prime. Okay. And then the product become C dot S prime plus B dot S. So you can write from this, you can write law like this. Okay. The reaction involving either single or dual step mechanism described above sometimes referred to as following Langmuir kinetic. So you have to, this is Langmuir is about the graph that we start learn in absorption. Okay, and then the third one is, okay, the first is absorption, and then surface reaction, and then the third one is desorption. Okay, no. This is still no, still surface reaction. Okay, so one is single site, this is dual site. For surface reaction, this is allyridial. Allyridial is about you have two reactant, but just one attached or deposit on the site, but the other one is gas phase. So gas phase, no attachment to the site. So like this we call it allyridial mechanism. So when the question asks for allyridial, so you have to imagine like this. Okay, and then the product become C attached to the S and D. G. So you have to write the red law like this. Okay, A dot S C A dot S B the apa species B, so become this is gas, so PB, partial pressure for B, then minus C dot S, and then PD. Okay, so this is 3 type of surface reaction: single site, dual site, and then allyridial. So I don't know which one will be the question for your final exam. Okay, and then this is the last one, desorption. After adsorb, surface reaction occurred, and then the product must be desorbed from the site. So for example, the product is C, so C dot S must be desorbed and then become C and also the vacant site. Okay, so the red law RD equal KD C dot S minus PC plus CB. Okay, and this is the desorption is reverse of the adsorption. Okay. Okay. now you have learned 3 steps, the important step in the catalytic reaction, which are adsorption, surface reaction, and also desorption. So within these 3 steps, you have to determine just one, which is the rate limiting step. What is rate limiting step? Rate limiting step is the rate controlling step. In these 3 steps, you have to know, or you have to determine which one the important step that control the reaction. If you know, so you can run the reaction. That's why you have to know the rate limiting step for that reaction. Okay, when heterogeneous reaction are carried out at steady state, the rates of 3 steps in series, absorption, surface reaction and desorption are equal. Okay, in a steady state, all are equal. However, just one particular step in the series is usually found to be rate limiting. Just one. Okay, so your task in final exam, I think you have to determine, usually you have to determine which one is the rate limiting step. Okay, if we could make the particular step go faster, and then the entire reaction would proceed at the accelerated rate. Okay, this is for for textbook. Okay, I think in textbook there there is a one figure showing the electrical circuit with 3 resistant with 3 resistant. So if we can control one of the resistant, so we can control all the circuit. That's analog for this reaction. Okay, so which step is limiting the overall rate of reaction? Okay, so you have to determine. So this is the example. Okay, synthesizing, how to determine. How to determine. So synthesizing a rate law mechanism and determine rate limiting step. For example, in your textbook, we have a decomposition of cumin. This is cumin with C and then C H3 of cumin decompose to form benzene and also propylene. Okay, this is the sequence of step in reaction limited catalytic reaction. So you can imagine this is a cumin reactant approaching the site, okay, and then attached to the site. What we call it, adsorption of cumin. When the cumin absorbed, this is catalyst, then the reaction occur. Okay, the reaction becomes surface reaction because of decompose to this and this. So after attached, surface reaction occurred, and then the benzene still attached, and then the propylene is here. Okay, this is what we call it, the reaction, early radial reaction. Early radial. Okay, this one. Okay, you can see early radial, like early radial. And then dissolve both dissolve of benzene. This is just benzene. Propylene is not attached, so just desorption of benzene. So 3 steps represent the mechanism of cumin decomposition. Okay. So this is adsorption. C plus S attached. C cumin attached to the site. So this is adsorption of cumin on the surface of catalyst. Okay, after the attachment, the adsorb C dot S will produce B dot S. The attached B attached to the site plus propylene. Okay, surface reaction to form adsorbed benzene and propylene in the gas phase, and then it should be after that, after separation, the product must be dissolved. So you just take it, you just take a B. Okay, you do not have to consider the P. Just take the dot one. Okay, B dot S, and then dissolve become B plus S. This is desorption of benzene from surface. Okay. So CC become CC become PC. This one is where PA partial pressure for C. See, this one, this one. Okay, and then this is the red law for all the steps. This is the absorption, so you have to write like this. PC, CC become PC. CV, sebab CV because of site. Vacant site. C vacant minus C dot S, and then like this, and then you know this one become like this, and then this one become like this. Just go with the red law for reversible reaction. Okay, and then desorption is just the reverse of the absorption of benzene. Okay, B dot S, this is dissolve. Dissolve become benzene and site. This is the absorption, is the reverse of the desorption. Okay, and then you can write like this, right? RD equal KD CB dot S minus this is actually KB, this is CBN. Because KB, this one, you can write also like this, okay, because this one. So no accumulation of retin species on the surface. The rates of each step are all equal, okay. So from that reaction, how to determine which one is the rate limiting step or rate controlling step from that 3 steps? So how to determine? You have to determine I think I WhatsApp you last Sunday, one page in your textbook, SKTK. Can you see your WhatsApp? I WhatsApp you the page, one page in your textbook. Okay, that is what? That is the algorithm how to determine reaction mechanism and kind rate limiting step. Can you see your WhatsApp?
Yes, doctor.
Okay, that's very important. Actually, if you can remember, sometimes the question give you a set of data, okay, and then you can plot the graph, and then okay, let's see the slide. Okay, this is you have to like chapter 5, you have to try and error, okay, which step is the rate limiting step. So you have to do all the if you see the WhatsApp also, okay, the WhatsApp number 1, okay, you can see for me for your if me I will write all the red law for the 3 steps, okay. If you can see your WhatsApp, so the number 1 is select a mechanism. This is for dual side, for the isomerization of N-pentane to isopentane. N is normal, normal pentane to I is isopentane. Okay, for me you have to write all the red law. First you have to write all the chemical equation, okay, the reversible reaction, and then you have to write all the red law, okay, just write all the red law, and then you can see number 2, you have to assume a rate limiting step. Which one? Okay, which one is rate limiting step? If you see your WhatsApp, you can see first, since more than 75% of all heterogeneous reaction are not diffusion limited no, 75% of the heterogeneous reaction, the rate limiting step is the surface reaction. So you have to try first with the surface reaction. Okay, number 2, you can see they try with the surface reaction. Surface reaction you can see N, your what's up, N dot S plus S, and then to produce I dot S plus S. Okay, in this textbook, they put all as a CC, all, betul lah. Okay, so K in bracket CS, CV, C vacant, and then Cn dot S minus Ci dot S, Cv, over K S, surface reaction. Okay, so you have to try first with the surface reaction because of 75% of the heterogeneous reaction, their rate limiting step come from is surface reaction. Okay, and then what happened to the other two red law? You have to use that red law to and then you replace for the RS, red law for the RS. You can see from the WhatsApp, step number 3. At equilibrium, all the RD and all the rate of absorption and also all the rate of desorption equal 0. So when equal 0, if you here there is no they do not write for the rate law for the absorption and desorption. But if you write the absorption and desorption, you can get the Cn dot S equal Pn Kn Cv. And then for the desorption, you can get from the desorption is C I dot S equal Pi Cv over Kd or K Ki Pi Cv. Okay, so you have to put both of Cn dot S and Ci dot S. You replace introduce to the red law of the surface reaction. Okay, and you cannot forget about the C total. What is C total? C total is C vacant plus C which is the species have dot, so this one is Cn dot S plus Ci dot S. Okay, Ct. So if you replace all this one into the red law of the surface reaction, you can get the overall complex equation become like number 5. Okay, can you see become number 5, and then you have to simplify the complex reaction. You can see they simplify all the Ks, Ci, and Kn become to small k. And then you have, after that, after you get the complex reaction, you have to compare this red law with the data given. Okay, so if the data is fit with the if the red law is fit the data, so that is the rate limiting step for your reaction. Okay, so come back to the slide. Okay, so for the cumin reaction, first one, if we just learn, if we try the absorption as a rate limiting step, so you have to write the red law like this, and then you have this is for the surface reaction. Okay, that's why I said you when you get the question, you have to write all the chemical equation, and then for 3 steps, and then write the red law for 3 steps, because you will use the red law. You see, even this is for absorption, but you use the RS because in your absorption here you have the C, so to replace this one with this one. Okay, and then you have the you also have you have to use the RD, okay? The RD, if the RD equals 0, you can get this one, you can get B dot S. So in here you have C dot S, but in C dot S you have CB dot S. So you have to use this CB dot S, put into the C dot S and then put here. Okay, you can see the relationship. So the RD become complex like this. Okay, and then you have another one. Where the CT? CT. No CT. C total. This is for the when the RAD equals 0, the relation become like this. Okay. This is the CT, okay? Because you have both the C dot S and CB dot S, so you have to write like this to get the CT. Why you have to write the CT? Because you want to write this one, the CB, in terms of all this one. So you have to put into the, when you put into the CV in this RAD equation, okay, this one, you can get the overall rate law for RAD is like this, okay? So initially no product are present, so you can cancel this one, become 0, okay? Because the PB and PP equal 0, so you can you have to simplify the complex equation to be like this, okay? And then if the absorption were rate limiting step, then the data should show like this, okay? So like I said, you will have a set of data, okay, in table usually, okay? And then you have to determine which one is the rate limiting step for direction. So if you get the rate limiting step, the correct one, the data should match with the graph, okay? So this is for the rate limiting step, and same goes for the next we try for the surface reaction. Surface reaction, and then same, you want to see the ending, So this is for the surface reaction. If the surface reaction, the data become like this, okay? And no, the surface reaction, the graph is like this if it is surface reaction. Okay, and then same goes for the desorption, okay? You do the same step, and then if desorption were rate limiting step, the data should show like this, okay? So you can see this is the graph for the absorption step. This is for the surface reaction step, and then this is for the desorption step. And then the data, you know, the data of the reaction is like this. So which one is the rate limiting step? Hello. Which one? The absorption, surface reaction,
Surface reaction.
Surface reaction.
surface reaction. Okay. Okay, you can see balik semula. This is for the desorption, different kan? This is for the surface reaction, and then this is for the absorption. You can see. Do you understand? Long journey, too complex, but you have to write like this, and then you have to match this with the data given, okay? And then from this you can determine the K or whatever, what we call it, from the what we have learned, the Langmuir-Sherwood kinetic model, okay? So this is the data from experimental observation. Okay. Okay, I think that's all. Ni absorbing inert. Okay, this is the red law for the case of no inerts absorbing on the surface. Okay, you have to read the textbook. Okay, there is many example for the red law. For example, this one, if you get like this, you can see you can assume or not assume, you can know that the red law for the case of no inerts absorbing on the surface. If no inert, the reaction become like this. This one, if inert would not participate in the reaction, or this one, or inert is not participate in the reaction but would occupy site on the catalyst surface. Oh, okay, this is inert. Okay, this is side valent. If the inert, okay, as if the inert inerts present in that reaction. Okay, so if inert present, you have to consider not only the species for the reactant and products, but also the inert for the CT equation. Okay, and for the side balance. Okay, please remember this one. And then this one, the absorption of the inert is at equilibrium, so the concentration of site occupied data. If the inert, if inert is present in that reaction, the CI dot F become like this. Okay, therefore absorbing inerts become like this. This is with inert. This is without inert. What is the difference? If you can see, no, you can see at the bottom ni, if inert present, you have the KIPI here, but this is no inerts. Okay, so sometimes they give you this complex reaction, and then they ask you to derive from the first one, from that 3 step until you get this one. Okay, so you have to do what I WhatsApp you. We have to do all the step. Okay, this is for example A to B. Okay, step in catalytic reaction. In I think in there is many example in your textbook. This is absorption on surface. You know A plus S is A plus S to A dot S, and then surface reaction you have, if this reaction so if this reaction, the surface reaction, just single side and dual side. The single side is same A dot S to B dot S. The dual side is A dot S because only A is the reactant, no other reactant. So if dual side, you have to put the S. One is vacant side. Do you understand? If the question will usually will say single side or dual side for one reaction, something like that. So you have to write for the chemical, this catalytic mechanism, this equation you have to write. Okay, so if just A, just one reactant but dual side reaction, so we have to write like this, and then the absorption is reverse of the absorption. Okay, and then for example A plus B to C plus D. So the absorption, if the absorption must be A plus S, B plus S to A dot S, because both B dot S, and then the surface reaction, because of two reactants, cannot be single side, have to can be dual side or allyridial. Okay, dual side become like this. This is the same shape of the side. If you can remember, this is the different shape. Prime, okay, prime, S prime, and then if allyridial, one is attached, one is not attached on the side. So gas, okay? So you have to know. And then this option is the same, the reverse of this. So both dissolve from the surface, okay? You have to know this one, how to write this one, because from this one, you write the red law, and then you choose the surface direction as the limiting direction, and then you replace what is the dot dot one in the red law of the surface direction, and also the CV. Okay, the CV you can get from the CT. Okay, the dot one you can get if you assume the red law is surface direction. The dot dot one you can get from the red law of absorption and desorption. Okay, this is irreversible surface direction limiting red loss. Okay, single site. This is irreversible. Okay, direction can be irreversible or reversible. So if there's irreversible single site become like this. Okay, and then this is you have to remember lah. But this is a see you can refer because online and so you can refer to your note and to your notes or your textbook. This is the red law for the this one. Okay, this is the graph. Okay, if they want you to get the K or KA, this is you can get the intercept, you can get K, and then you can get KA from the when you get the K, you can get the KA. So when you want this type of graph, you have to put the y-axis is like this, x-axis is like this. So you can put you can rearrange the red law become y is this, x is this. Okay. Then this is dual side. Okay, dual side. So the dual side, the RA absorption become like this. This is the and then become like this. Usually, if you see this one, this is single side for irreversible. You can know the red law is become like this if you go for the absorption. No, surface reaction. This is all the surface reaction limited. If the reaction is single, you can get the equation like this. If the dual, you can get the last final red law is like this. Okay, this is if a not a zero. So the PA at initial at initial. Okay, the initial PB become 0. Okay, so you just get this one. Okay, so become like this. Then the dual side. If dual side like this, become like this. Okay, you can see the reaction different. The red law different. You can see there's KA, PA, KB, PB. But this one because you have C, so you have to we have C here. You can try from your you can try by yourself. You can get this one for the final answer. If you choose the surface reaction is the red limiting step. Okay. This is early radial. If early radial, you can get like this. Early radial for this one. Okay. C dot S. Only C dot S. Okay, I think that's all. That I said you get the slide or notes for chapter 10 from the Tahaja group. Okay, because the Tahaja I think give the example. Okay, I do not have the example here. So you can refer to the Tahaja slide on also. Okay. Do you understand? This is all for chapter 10. At the back of the textbook of chapter 10, you can see several example for chapter 10. Sometimes they just give you the complex ration, the complex. Sometimes they just give you, I don't know, the this time of final exam question. I cannot see. Sometimes they just give you like this, and then please derive from from first step from the absorption, like I send you in WhatsApp to get this one. Okay. Sometimes they give you the table, a set of data, and then they give you the condition of the ration, and then the question want you to check whether your rate limiting step is fit the data or not. Okay, sometimes they want you to calculate for this one for the graph, and also they can ask you about the volume. Okay, the volume will come back to the previous one, whether the isothermic or non-isothermic, or CSTR or PBR or PFR, something like that. PBR or CSTR. Okay, for the volume. Maybe they can ask you also for that one. I think chapter 10, the question come from, I think, who and Dr. Izian ke? Maybe. Forgot the name. Okay, any question? So, we just have next week kan? Next week is the last week. So, please find the different type of question for Sunday and Wednesday next week. Okay, different type, okay? Any question? Can you understand? Hello, hello? Senyap
No,
boleh. I stop sharing. I promise you to give the carry mark before the final exam, right?
Yes, doctor.
Inshallah, inshallah. Inshallah, I will do. Okay, 10 February, right? Your final. Kan?
Yes, doctor.
10 February. Okay, I have 1 month kah? 3 weeks only. 3 weeks kan? To do. 2 weeks kah? 2 weeks kah? Inshallah, inshallah. Okay, any question? No question?
Doctor, for
Huh?
the presentation slide on PDF, doctor, doctor, because the last week you do ask us to compile the PDF as email to doctor, right?
PDF, that is for the assignment, right? Kan? Huh?
For the is it for the presentation one? The
No,
presentation.
presentation. Who
No,
will present? Huh?
no, the one that we present in class.
Okay. Yes, that one. So, for example, your group, just one question and answer for one chapter, right?
Yes, doctor.
So, you cannot compile. You can compile, or you can compile for your group only.
Yes, doctor, can compile.
Okay. So, what is the question? Go.
So that we need to compile everything into PDF form and email to doctor, right? For our group only, not include other group, right?
Okay, okay lah. For each group, chapter 1 until chapter 10. Okay, you compile question and answer. Okay.
Okay, doctor.
Okay, for each group. Okay, so for each group you have 8 chapters, question and answer. So eight question, 8 answers, right? 8 kan?
Yes.
Apa? 6, 8, 10, 8. Okay. For each group you have 8 question and 8 answers. Kan? I want the proof, okay, to upload to my test, okay, my system. They want the example what I teach in the class. Okay, the evidence. So I will upload your PDF file. Okay, no question? If no question, see you on Monday next week. Okay, on Sunday next week. Okay. Okay tak? You can leave now. Go kenapa?
Thank you.
Oh, thank you. You have no question? You want
So
to ask?
far, no. So far, no,
Okay.
doctor.
Okay, it's okay. Okay. Okay.
Thank you,
Good
Prof.
luck.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
To find the good result.